We spent $2.3 billion building the James Webb Space Telescope, the most advanced optical instrument humanity has ever created. 18 gold-plated mirrors, each polished to an impossible level of precision. We can see galaxies over 13 billion light-years away. But here's what should keep you up at night. There's a carved stone disk sitting in a museum in Cairo that we still can't recreate with all that technology. Not theoretically, not we haven't tried hard enough. I mean, we have physically tried to copy it using modern computer-controlled machines, diamond drill bits, and robotic arms, and we've failed. It's called the Schist disk. In ancient Egypt around 4,500 years ago, and it represents something way more disturbing than ancient aliens or lost civilizations. It shows us that maybe we don't understand precision the way we think we do. Welcome to the archaeology of humiliation. Let me describe what you're looking at. This is a circular plate, about 2 feet across, carved from a single piece of schist, a type of layered rock that's harder than most ancient tools, but softer than steel. The disc has a perfectly circular hole in its center, about 4 inches wide. The edges are cut at a precise 22-degree angle. The surface finish, and this is where it gets really weird, is mirror smooth. We're talking about a level of polish that matches modern manufacturing standards. Here's the problem. Schist is a rock made of layers, like a stack of paper. It wants to split and crack when you work with it. Imagine trying to carve a dinner plate from a stack of wet playing cards. That's basically what they were dealing with. In 2017, an engineer named Christopher Dunn tried to make a copy using a modern machine shop. He had access to cutting tools spinning at 3,000 rotations per minute, computer-guided machines accurate to within a tiny fraction of a millimeter, and industrial diamond grinding materials. The schist would split. The surface would get pitted and rough. After 6 attempts and nearly 50 hours of machine time, he produced something that looked generously like a failed art project. Now let's talk about the mental trap we've all walked into. This is what I call the tyranny of progress, an assumption so deep in how we think that we don't even notice it. We assume, almost like a religion, that technology only moves in one direction, forward. That every generation knows more, builds better, thinks clearer than the last. It's the core belief of modern thinking, and the schist disk basically calls it a lie. The disk was found in the tomb of Sabu, a high-ranking official during the reign of Pharaoh Agib, around 2800 BC. This was the First Dynasty, a period we've labeled as Early Bronze Age, as if calling it early somehow makes what they achieved less impressive. The state was organizing workers on a massive scale, building monuments that would dwarf anything Europe would attempt for another 3,000 years. But here's what we miss when we just focus on the giant pyramids. The Egyptians of this time had developed something way more advanced than the ability to stack stones. They had what I call patient knowledge, a way of making things that's completely opposite to our modern rush, fail-fast mentality. Think about what it means to work schist by hand. You can't force it. Push too hard and it shatters. Work too fast and you create heat that makes cracks spread through the stone. The only way to get that mirror finish is by removing material so slowly with such light pressure that you never stress the stone's structure. We're talking about grinding compounds, probably quartz sand mixed with water, applied with bronze or copper tools, worked in circles for hundreds, maybe thousands of hours. One disc, one person's lifetime of knowledge, passed down through years of training. The craftsmen who made this didn't have computer files or measurement specifications. They had something more powerful. They had the ability to feel, through the resistance in their hands, exactly how the material wanted to move. This is understanding at a physical level, and we've completely removed it from how we make things. Our modern manufacturing is based on force. We use super hard materials to bully the schist into the shape we want. We spin cutting tools at speeds that create enough heat to change the material, then wonder why it breaks. We've optimized for speed, and we've lost understanding. The Egyptians got something we've forgotten. That precision isn't just about measurements, it's about relationship. That you can't force beauty into existence, you can only guide it. But let's go deeper, because the schist disk isn't alone. In 1936, a German archaeologist named Wilhelm Koenig was sorting through artifacts in a museum in Iraq when he found something that shouldn't exist. A clay jar, about 5.5 inches tall, from around 250 BC. Inside the jar was a copper cylinder. Inside the cylinder was an iron rod. The jar had been sealed with tar. Koenig, being curious and a little reckless by today's museum standards, poured an acidic liquid into the jar. It produced just over 1 volt of electricity. He had just turned on what we now call the Baghdad Battery, and in doing so, he basically exploded our understanding of ancient technology. Now, before everyone starts yelling, let's be clear about what we're saying here. We're not claiming the ancient Parthians had electric lights or built computers. We're saying they figured out electrochemical reactions that we didn't officially discover again until Alessandro Volta's experiments 2,000 years later. Here's how it works. The copper cylinder was about 4.5 inches long and 1 inch across, wall thickness about 1 millimeter, which is thin. The iron rod sat in the center, held in place by tar that kept the two metals from touching. When you fill this setup with an acidic liquid, you've just built what's called a galvanic cell, a battery. This isn't guesswork. In 1978, scientists in Germany built 10 exact copies using materials the Parthians would have had access to. Copper with a bit of arsenic mixed in, iron made the way they made it back then, and tar from the same area. They filled the jars with grape juice, an acidic liquid that would have been common. Average output? About 1 volt. Connect 10 jars in a chain, and you've got 12 volts. That's enough power to coat silver with gold, a technique we know the Parthians were really good at. When these replicas were published, the response from academics wasn't curiosity, it was anger. Why? Because the Baghdad Battery broke the story we tell ourselves about progress? We've built our entire self-image as a civilization on the idea that we're smarter than our ancestors. That scientific knowledge moves in a straight line from ignorance to understanding. The Baghdad Battery suggests something scarier. That knowledge can be discovered, lost, and rediscovered. That progress isn't a ladder, it's a maze where you can get lost. The Parthian Empire existed from 2047 before count to 2024 after count, controlling land from modern Turkey to Afghanistan. They were Rome's rivals, and they existed in this fascinating cultural space where Greek philosophy, Persian engineering, and Mesopotamian craft traditions all mixed together. This wasn't some primitive backwater. This was a sophisticated empire with trade routes connecting China to the Mediterranean. The economy demanded innovation. The Parthians controlled the Silk Road, which meant they were middlemen in the luxury goods trade. Gold-plated jewelry, religious objects, fancy weapons, these were high-profit exports. If you could coat things with gold instead of using solid gold, you could massively increase your profit while maintaining the expensive look. And here's the human element we always forget. Some Parthian craftsman, whose name we'll never know, was probably just trying to solve a boring everyday problem. Maybe they were trying to preserve food in acidic liquids. and noticed their copper containers corroding in weird patterns. Maybe they were trying to create a certain color on bronze sculptures and stumbled onto electricity by accident. The point is, they observed, they experimented, they tried different things. We've made it seem like the scientific method was invented in Europe in the 1600s, but the Baghdad Battery proves that experimental thinking is just part of being human, not a Western invention. The difference is writing things down. The Parthians didn't publish research papers. They passed knowledge through craft guilds, master teaching apprentice, and word of mouth. And when those systems collapsed, during endless wars between Rome and Persia, during Islamic conquests, during Mongol invasions, that knowledge just evaporated. This is the tragedy of knowledge that isn't written down. It's tough in stable times, but incredibly fragile during chaos. One generation where the teaching gets interrupted and it's gone forever. Now let's talk about something that makes the Baghdad Battery look simple. Let's talk about Roman concrete. In 1961, the US Navy needed a new harbor in Italy. Sachs and Moscow, an old Roman seawall, built in the 1st century AD, was in the way. So they did what seemed reasonable. They tried to tear it down. They used jackhammers, delivering 4,000 hits per minute at 90 pounds per square inch of pressure. The concrete laughed at them. They upgraded to diamond wire saws. The concrete dulled the diamonds. Finally, they brought in military explosives designed to blow up reinforced concrete bunkers. The Roman concrete cracked. Barely. Engineers from MIT later looked at what remained and found something impossible. After 2,000 years underwater in corrosive salt water, the concrete had actually gotten stronger. Modern concrete, the stuff we use in 90% of construction worldwide, lasts about 50 to 100 years in ocean environments. The chemical process is simple and brutal. Seawater contains salts that get into the concrete, react with the chemicals in the cement, and form compounds that create tiny cracks. Those cracks spread, the metal reinforcement rusts, and eventually the whole thing falls apart. We accept this as just how it works, and we design buildings knowing they will need replacement. The Romans built for forever and accidentally succeeded. Here's the chemistry. Roman concrete used a specific type of volcanic ash called pozzolana, dug up from quarries near Mount Vesuvius and other volcanic areas around the Mediterranean. The key ingredient is a type of volcanic glass that forms when lava cools really fast. When you mix this volcanic ash with lime and seawater, something remarkable happens. The volcanic material reacts with the seawater to form crystals of a rare mineral that actually grows denser over time, as it pulls magnesium from the seawater into its structure. In 2017, scientists from universities in California and Utah analyzed samples from that seawall in Brindisi. They found these crystals, some up to 50 micrometers long, interlocking in a three-dimensional grid that basically makes the concrete self-healing grid. Wherever tiny cracks form, seawater gets in, and more crystals grow, sealing the crack. Modern concrete can't do this because we optimize for getting strong fast. Portland cement, the standard type, reaches 70% of its design strength in 7 days. That's important when you're building a skyscraper and need to move to the next floor on a tight schedule. But that rapid strength comes at a cost. The chemical reactions create a lot of heat, make a denser but more fragile structure, and leave unreacted cement particles that become weak points. Roman concrete took years to reach full strength. The volcanic reaction is slow, happening on geological timescales. But the end result is almost like a living material. It responds to its environment. It adapts. Now here's the mental disconnect we have to deal with. We know exactly how Roman concrete works. We've reverse engineered it completely. We could start using it tomorrow. But we don't. Why? Because it doesn't fit how we build things. Our entire construction industry is built around speed. Contractors lose money for delays. Projects have financing costs that add up every day. The idea of pouring a foundation and waiting 5 years for it to cure is economically unthinkable. So instead, we build bridges that need replacing every 50 years, harbors that need constant maintenance, and infrastructure that creates an endless stream of repair jobs. We've confused planned obsolescence with efficiency. The Romans lived in a different reality when it came to time. The empire, at its peak, controlled 55 million people. It had existed for centuries and, from the view of a Roman engineer in the 1st century AD, would exist for centuries more. Why wouldn't you build things to last forever? The mental framework was completely different. They thought in terms of generations, assuming your great-grandchildren would use what you built. We think in terms of quarterly earnings reports. Marcus Vitruvius, who was an ancient Roman architect, talked specifically on this. He gives exact ratios: 2 parts volcanic ash to 1 part lime, mixed with seawater right at the construction site. He understood, even if not scientifically, that the seawater was part of the curing process, not just a convenient liquid. Vitruvius was writing during the reign of Augustus, the first Roman emperor, around 15 BC. This was the Pax Romana, a period of crazy political stability and economic growth. The empire was building infrastructure on a scale that wouldn't happen again until the Industrial Revolution. Roads, water systems, harbors, stadiums, and all of it built with this remarkable concrete. But here's what haunts me. The knowledge of Roman concrete was lost by the 6th century AD. Not because Romans stopped building, it was lost because the economic and political systems that supported long-term thinking collapsed. As the empire broke apart, as trade routes became dangerous, as the quarries in volcanic regions became unreachable, builders started using whatever materials were nearby. They switched to lime mortars, which are easier to make but way less durable. Within 200 years, the knowledge had deteriorated so badly that medieval builders, looking at Roman structures, thought they were built by giants or wizards. The technical ability to analyze and copy Roman concrete didn't exist again until the late 20th century, 1,500 years later. This is how fragile technology really is. It's not the tools that matter. It's the social systems that keep the knowledge of how to use them alive. Let's shift to something that works on an even more disturbing level. Let's talk about the Antikythera mechanism. In 1901, Greek divers looking for sponges discovered a shipwreck off the island of Antikythera. Among statues and pottery, they found a corroded lump of bronze gears. For decades, it sat ignored in museum storage. In 1951, a British physicist decided to X-ray it. What he found completely changed our understanding of ancient technology. The Antikythera mechanism is an analog computer. Not metaphorically, it is an actual geared calculating device with at least 37 interlocking bronze gears, the biggest with 223 teeth, designed to predict astronomical events, including solar eclipses, the positions of the 5 known planets, and the phases of the moon. It dates to about 100 BC, and it represents a level of mechanical complexity that we didn't match until 14th century Europe, 1400 years later. Let me describe what you're dealing with from an engineering perspective. The gears are made of bronze, about 2 millimeters thick, cut with triangular teeth to reduce slipping. The tooth shapes aren't rough castings. They're precisely cut with gear ratios that use fractional relationships. For example, The moon phase display uses a 53-tooth gear connecting with a 96-tooth gear, creating a ratio that closely matches the lunar month when combined with other gears in the system. But here's the really scary detail. The mechanism includes what engineers call a differential gear, a device that adds or subtracts the rotation speeds of two input shafts to create a third output. Differential gears are complicated. They require precise understanding of how motion relates and transfers. We use them in car transmissions. The ancient Greeks built them to model the oval-shaped orbit of the moon, accounting for the fact that the moon's speed varies throughout its cycle. This means someone in the ancient Greek world understood that orbits aren't perfect circles. They understood that the moon's speed changes. They created a mechanical model accurate enough to predict eclipses years in advance. And they did it without calculus, without Newton's laws, without any of the math we consider essential to understanding orbits. When modern experts built a working copy using old techniques, hand-filing bronze gears and drilling holes with bow drills, it took a master clockmaker 3 years of full-time work. 3 years to copy a device that someone, whose name we'll never know, designed and built as probably one example of a whole type of such instruments. Because here's the thing that should shake you. The Antikythera mechanism wasn't unique. We know this because the craftsmanship is too refined, too confident. This was mature technology. Someone had built practice versions. Someone had improved the design over time. Someone had trained students. This wasn't one isolated genius. This was the product of an entire technological tradition that we only know existed because one mechanism happened to sink in a shipwreck and get preserved. How many others didn't survive? How many were melted down for scrap metal during wars? How many are sitting in collections somewhere? The psychological impact of the Antikythera mechanism is what I call humility shock. It's the sudden realization that our map of history is wrong. We teach history as if technology steadily progresses from primitive to advanced. Nice, neat, linear. The Antikythera mechanism doesn't fit. It's an advanced computer appearing in what we call ancient times, then disappearing for over 1,000 years. This was created during the late Greek period, probably in Rhodes or possibly Alexandria, during the twilight of Greek science. By 100 BC, Rome was rising militarily but hadn't yet absorbed Greek intellectual culture. This was a world where the Library of Alexandria still stood, where scholars were making astronomical observations with precision that wouldn't be beaten for 1,500 years, where math, astronomy, and engineering were reaching peaks that medieval Europe would barely understand. But the political situation was unstable. The Greek kingdoms were being systematically absorbed by Rome. Rhodes, where this probably came from, was a wealthy trading hub increasingly caught between Roman expansion and resistance from the east. When Rome destroyed major Greek cities in 146 BC, the message was clear. The age of independent Greek city-states was over. The age of empire had begun. And empires don't value delicate astronomical instruments. They value swords, ships, and roads. The knowledge that created the Antikythera mechanism, the mathematical sophistication, the mechanical precision, the centuries of watching the sky, all of it became strategically worthless. This is the tragedy of practical thinking. Technologies don't survive because they're brilliant. They survive because they're useful to whoever's in charge. The Antikythera mechanism could predict eclipses, but it couldn't stop Roman legions. Now, let's talk about something that makes all of these look almost reasonable. Let's talk about the stone spheres of Costa Rica. In the 1930s, workers clearing jungle for banana plantations in Costa Rica started finding stone spheres. Hundreds of them. ranging from a few inches to over 6 feet across, made from granodiorite, a stone that's quite hard, carved into nearly perfect spheres with accuracy to within 2 millimeters on specimens weighing 15 tons. Let that sink in. 15 tons, 6 feet across and round to within 2 millimeters. We can barely do this now with computer-controlled grinding machines. The largest sphere weighs about 15 metric tons and is spherical to within about 4 millimeters of perfect. To put that in manufacturing terms, that's incredible precision. The ancient Costa Rican craftsmen got within an order of magnitude of what we achieve with computer machines and lasers. But they used stone tools, probably basalt hammers, maybe sand for grinding, and an amount of patience that would bankrupt any modern factory. Here's the technical problem. To create a sphere by hand, you need to constantly check your work against something. For small objects, you can use measuring tools. For a 6-foot sphere weighing 15 tons, you can't easily rotate it. You can't easily compare different parts. The mental challenge of keeping three-dimensional symmetry without measurement tools is staggering. A mathematician calculated that to hand-carve a sphere that size to that accuracy would require removing about 200 cubic meters of stone through grinding, checking thousands of surface points for distance from the center, and staying consistent across a huge surface area. The estimated time, assuming 8-hour days and a skilled craftsman with period tools, is somewhere between 6 and 8 years per sphere. For objects we still don't understand the purpose of, because here's the thing, we don't know what they were for. They're scattered across the region, sometimes in groups, sometimes in lines, sometimes apparently random. They're not grave markers. They're not tools. They're not obvious astronomical devices. They're just there, silent proof of an obsessive commitment to geometric perfection. The culture that made these flourished from about 7 AD to 1500 AD, though some spheres might be older. This was a complex society, with hierarchy and long-distance trade networks through Central America. They worked gold with advanced casting techniques, created intricate stone carvings, and apparently decided to invest thousands of hours of expert labor into creating perfect spheres.